Hello, we are the Team 5 and presentators are 이진웅 and 변상구. Presentation about Burj Khalifa will be started. We're gonna talk about general information about the project, main design issues, construction engineering issues, and other notable educational issues. At the first, general information. The original name of Burj Khalifa is Burj Dubai or Dubai Tower. But UAE provided funds to Dubai in hard time, so the current official name is originated from UAE president's name. There are basic information of Burj Khalifa. The official name is Burj Khalifa bin Zayed, and construction is started in January 6, 2004 and completed in October 1, 2009, and finally opened January 4, 2010. Architect is Adrian Smith, and structural engineer is William Frank Baker, and main contractor is Samsung Construction and Trading, and client is MR Properties. Total height is 828 meters, and floor count is 154 and added 9 maintenance floors. The client of Burj Khalifa is MR Properties. MR is the public construction company in Dubai. It is the world's largest real estate-based company and is listed on the Dubai financial market. Chairman is Mohammed bin Ali Arafat, and their services is commercial and residential properties development. The architect Adrian Smith was born in August 19, 1944, Chicago, Illinois. He had worked for Skidmore, Owings and Merrill until 2006, and there are building lists that he made. In 1971, Dubai joined in UAE, and Jebel Ali Free Zone was built in 1985. From 1980 to 1990, there are development into the popular business and tourist destination. Then in 2003, real estate reached a peak. Like other projects, this skyscraper is looking to attract world attention on the city because their oil is near finished. Dubai is betting that its economy to prosper through tourism. That is the main reason that many of these complexes are being built in Dubai alone. When announced in early 2003, the Burj Khalifa's design was the 560 meters tall, but in May 2003, a new design was released. In 2004, construction was started and became a world's tallest building in 2009. And finally, in 2010, Burj Khalifa was officially opened. Their goals are to achieve the title of world records and improvement popularity of UAE, and also they want to show their power and modernity. And last, revitalize the tourism industry to lighten the dependence on oil trade. Now you can see the today's condition of Burj Khalifa. MR spokesman say that there is significant demand for residential and commercial units in Burj Khalifa, especially in the secondary market, and more than 10 years after its completion, the building is still recognized in each country. In recent days, Google ranked third with a monthly search of 110,950 in the top landmark survey. And next is main design issues. Now you can see the floor plan of Burj Khalifa. There are 3 reasons that this plan was chosen. The first reason is design. It was inspired from desert flowers by the lily and used Islamic architecture that has geometric patterns. The Y-shaped floor plan is ideal for residential programs. It makes maximized window perimeter to floor plate area and inherently stable, so it has an advantage in securing the right to view. The second reason is safety. Burj Khalifa is composed of 3 elements, arranged around the central core. As the tower rises, one wing at each tier set back in an upward spiraling pattern, so the tower's cross-section area reduces gradually. This gradient spiral design makes to handle the swirling wind, and also it is subject to normal soil pressure like other low-rise buildings. This will be covered in more detail in the later construction sections. The last is flexibility. The building was designed to change its height from the beginning, so the gradient spiral design makes building to high-rise and narrow ground floor. You can see the sequence of construction, and in the next page, the result specific floor will be shown. The usage of Burj Khalifa is classified with three main categories. In first floor to 37th floor, there is the Armani Hotel Dubai, and in 38th floor to 108th floor, there are 1,000 residential units. And finally, in 108th floor to 154th floor, there are business space and observatory. And the mechanical floor also occupies the Burj Khalifa. Then you can see the detail of usage from communication to mechanical floor. Here is ground floor plan. You can see the separated entry for residential, hotel, and office. And each typical floors have different plan. In the hotel floor, there are studio and classic guest room and suite room. And the residential floor has the bedroom units. And last, office floor has office and cafe and meeting room. This is an example of how BIM is used. Here the software called Revit is being used to model the world's tallest building, Burj Khalifa.
Next, I want to talk about construction issues about sequence. Burj Khalifa was constructed in January 2004. The soil stratum of Dubai is very weak because of fragile rock, waste, groundwater. So they have to excavate up to 50-meter deep to get a hard rock structure. So part foundation and left foundation are needed. First, the part foundation. In the part foundation, the pile uses 43 meter of reinforced concrete pile, and they use 3.7 meter thick pile, support to the left 12,500 cubic meters of C50 SCC concrete. Piles made of C6 SCC concrete, placed by tramming method utilizing polymer slurry. Second, it uses left foundation. Left foundation is also known as mat foundation. It is used when load-bearing capacity of soil is very low and columns are closely spaced with each other, and it is used when a soil at site has a low capacity, thus load needed to be distributed over large areas, or the soil balance is unpredictable, which might result in individual footing failure. The soil stratum of Dubai is very weak, so they have to use left foundation. On the left, there is the drawing of foundation, and on the right, there is the look after the foundation is completed. Also, there is another construction issues about 3-day cycle process. Burj Khalifa is constructed by 3-day cycle process. 3-day cycle process is to construct one floor in 3 days. In short, Day 1, prefabricate columns and retaining walls on the ground. Day 2, install formwork and steel, considering openings related to equipment and electricity and windows. Day 3, after 10 and 12 hours of concrete pouring, remove casting. To construct Burj Khalifa, repeat these processes. Let me give you more details. Day 1, prefabricate columns on the ground. Then, we can have many advantages. First, control quality. Second, the number of workers going up, down the tower. And the lever was assembled in double-story modules to speed up the vertical element construction time. And Day 2, install formwork and steel. Working on the equipment or opening before pouring concrete and assembling formwork. Day 3. Concrete pouring. 3 major pumps were placed at the ground level. It is lifted with 200 hydraulic jacks without a tower crane. It sets a record of 600 meters tall, dielectric firing concrete. The technology is the key to this project. In a 3-day cycle, because of the extremely high temperatures in Dubai during the day, this can be as high as 48 Celsius degree. Concrete was poured on at night when it's cooler and more humid. In addition, ice was added to the concrete during mixing to cool it further. The reason behind this process is that concrete dries more evenly when cools and is thus less likely to form cracks. In such massive project, such cracks could have disastrous consequences. So the concrete floor behavior also had to be kept in check. To test it, a sample was poured on the plate and was deemed acceptable based on whether or not it sprayed out far enough. The concrete had to be as soft as water and needed high-strength hardening after construction. And high-strength concrete has high amount of cement, so despite the difficulty of mixing, special mixture have been added to make the project unstable concrete. All the strength of concrete was required by process on the third. The specially mixed concrete was tested each time to measure the correct strength. Having this consistent strength, hydration, heat, etc. of concrete space is a significant factor in building construction. And let me tell you details about the concrete. The high-performance concrete used in Burj Khalifa guarantee low permeability and higher durability. The C80 and C60 cube strength concrete is used in incorporating fly ash, Portland cement, and the local aggregate, etc. High-performance concrete C60 and C80 grade concrete was used for vertical members, and C50 grade concrete was used for horizontal members. In addition, the ice was added to the concrete mix instead of water, because the hydration heat must be fully managed. Due to the hot weather in Dubai, concrete work was carried out after sunset. The construction cost is a crucial factor for the safe and timely transport of the material, equipment, and manpower. The tower section is enclosed by podium. It is necessary to provide sufficient well-planned stockyard for the storage of material for the project and limited stock area for the tower section. The tower side area is about 100,000 square meters, in which includes the tower and podium. The podium is divided in Zone A, Zone B, and Zone C. Auto-climbing formwork system is critical role in order to construct one floor in 3 days. Another construction issue is curtain wall. There are many considerations because of the heat of degree, strong wind, strong sunshine, and sand dust. The 132,000 square meter curtain wall facade of the Burj Khalifa is made of aluminum, silicone, and glasses. It consists of over 24,000 panels, specially designed to save energy. As you can see the presentation, thin layer of metal can reflect ultraviolet light to block heat. Thin layer of silver can block the infrared rays that the sand reflects. Their high-performance reflect glazing greatly reduces the transmission, which is a critical feature in the extreme heat of Dubai. This page tells you use process in curtain wall. First, up and up process. Up and up, the set up panels simultaneously in 5 zones to reduce time. Second, infill system. Infill, that installs connecting panels between zones. Third, mega block unit process. Mega block unit pre-assembles and installs curtain walls of spire parts that are more than 700 meters. Next, I want to tell you about the notable issues. First, particle force by weight. Particle management is very important for high-rise buildings because of structure and high-speed level of problems. 3 methods are used to manage these problems. First, checking the vertical level with 3 satellites, named Global Navigation Satellite System. GNSS. Second, the GPS survey systems are used to correct these errors. Third, several hundred sensors are used to observe minute movement and load changes. It can maintain a vertical degree of error range of 5 millimeters. And another notable issue is lateral force. Burj Khalifa reinforced concrete shower and buttress core are interconnected to perimeter, and reinforced concrete mega columns to resist both lateral and gravity loads. And outrigger system. They were designed rigidly with outrigger every 30 floors to prevent wind-induced deformation. The mechanical floor is connected through columns to interior column system using outrigger walls. Due to this, the column participated in resisting the heavy lateral loads. Central core of hexagon shape provides torsional resistance to the structure. These walls behave like the web and planes of a beam to resist the wind shears and moments. And cross-sectional features. Buttress core gives buildings a stable triple stance. Narrow floors maximize both window access and usable spaces. And the higher the buildings, the more important it is to resist the lateral force, because the building is exposed to the lateral force causing the wind tunnel, and the wind load is increased as the height. Wind engineering is one of the primary concerns in the design of the tall building design planning. Over 40 wind tunnel tests were conducted on Burj Khalifa. Other notable issue is fire. There is a pressurized fire escape area about every 25 floors. The zone is constructed with a structure where the outwards are finished with a special fire resistant and can put into only enter outside air. So, a total of 6,500 people can be saved for 2 hours, even if a fire breaks out. In addition, there are various fire exhausting functions, such as sprinklers, hatching warning systems, and fire alarm systems. It's very important for emergency personnel, for example, firefighters and paramedics and police, can access a building quickly in the event of an emergency. These are very fast, and these are configured to override the local elevators to allow for the quickest exit transfers. Also, the elevators themselves are fire smoke resistant, so it is very safe. And water pipe for the protection is 132 miles. And its floor is outfitted with a smoke compartment that traps and contains smoke. Finally, a smoke control panel will be provided to emergency personnel. This will allow firefighters and paramedics to manually adjust the smoke control system at their directions. Other notable issue is stack effect. First, stairwells are not in a continuous shaft. Second, extra set of doors were placed between residence towers, elevator shafts, and lobby areas. Third, major air systems in the tower have various speeds, so this allows them to react in a range of pressure conditions. First, outside air intake and exhaust system have monitoring system for added control. Fifth, the smoke exhaust system doubles as pressure relief to avoid overpressurization. Earthquake is another notable issue. Preventing earthquakes in high-rise buildings is very essential. The Burj Khalifa was also designed to prevent earthquakes and minimize damages. The Burj Khalifa building has the capacity to withstand earthquakes up to 7.0 magnitude. And since completion of the installation of SHM program at Burj Khalifa, most of the structural system characteristics have been identified and included measuring the following. First, building acceleration at all levels. Second, building displacement at level 160. Third, building dynamic frequencies including higher modes. Fourth, expected building damping at low amplitude due to both wind and seismic event. And another notable issue is water supply system. The task of pumping water skyward through the Burj Khalifa is a formidable one, and engineers know having one giant water pump do all the works would be dangerous. So they created a system that pumps water to a series of tanks at a different level throughout the building. These tanks are housed on the 7 2-story mechanical. Air conditioning is other notable issues. As a building, cladding composed mainly of a unitized glaze and a curtain system in a scorching desert. Keeping the building cool was the main concern. So the question was how to do this effectively or efficiently. A solution was devised using an innovative cooling method that involves plate heat exchangers and a thermal ice storage facility that produces ice slurry during the ice cooler times or at night. This ice slurry is stored in a tank, and during the day or hotter times, the hot plate exchangers forced by alpha lava release the cool energy through the pipelines. This can cooling the buildings. There are two main benefits of using these ice storage solutions. First, substantial energy savings, and second, it only requires a fraction of the space needed from the convection cooling equipment. And air handling unit is used. This used to circulate air as a part of heating, ventilating, and air conditioning system. Second, air handling unit can improve the air quality of the tower by using the air on the higher level, which is clean, and cooler air and transfer it to the lower floor. This page shows each other's floor. 진웅 Lee, 상국변, make PPT about part 1 and part 2 and presenter. 현준 Che, Yongtaek Shin, search part 3 and make PPT about part 3. Minji Chang, Sungwon Ho, make part 4 and make PPT about part 4 and arrange all PPT. Thank you for listening.